You know that feeling, right? That weird, invisible force from the magnets you played with as a kid? It almost feels like magic. Well, today we're going to pull back the curtain on magnetism. We're talking about the force that pushes and pulls, all without ever touching anything. So let's dive into this incredible invisible dance. I mean, just think about it for a second. When you go to stick a magnet on your fridge, you feel that little tug, right? That distinct thump as it just leaps from your fingers. What you're feeling is a force that's literally acting across a distance. It's a push or a pull working through what looks like, well, nothing at all. So there's a name for this, of course. Physicists call it a non-contact force. And it's not the only one, you know? It's pretty much the same idea as gravity keeping your feet on the ground. I mean, there's no invisible string tying you to the earth, but that force is definitely there. Magnetism works in exactly the same way, and it shapes everything, from the smallest atoms to, believe it or not, the biggest galaxies. Okay, so how does this invisible force even decide if it's going to push or pull? It seems so mysterious, but it actually boils down to one simple, really fundamental property, and that's called polarity. And here is the one rule you have to remember. It's super simple. Opposites attract, and like poles, they repel. I mean, if you've ever tried to push two north poles of a magnet together, you can physically feel them fighting you. But bring a north pole near a south pole, whoosh, they snap right together. It's a simple, totally predictable, and seriously powerful principle. Right, so this isn't some kind of magic trick, it's just pure physics at work. That push and pull we feel, it's all caused by something we call magnetic fields. See, when the invisible fields from two different magnets get close, they start to interact, and depending on how they line up, they'll either pull the magnets together or shove them apart. So I keep mentioning this invisible field, but what in the world is it? And, the bigger question is, how can we possibly see the shape of something we can't, well, see? Well, a magnetic field is basically the area around a magnet where its power can be felt. You can almost think of it like an invisible web, or maybe the architecture of its force, that stretches out from the magnet's poles. Anything magnetic that wanders into this field is going to be affected by it. No question. But that's the million-dollar question, isn't it? If it's invisible, how on earth do you map it out? Well, lucky for us, scientists figured out a really clever and classic trick for making the invisible visible. And that trick is the famous iron filings experiment. It's one of the coolest, most classic ways to see what's going on. If you just sprinkle tiny little bits of iron around a magnet, they don't just fall wherever. Not at all. They actually line up perfectly and trace the shape of the magnetic field. You get these beautiful, elegant arcs flowing from the North Pole to the south. And hey, you see where the filings get all bunched up and dense? That's right near the poles, and that tells you exactly where the force is the strongest. Okay, so theory is one thing, but let's be honest, the best way to really get a feel for science is to see it in action. So let's walk through a super simple little investigation that you could honestly try at home. We'll call it the magnet interaction test. So imagine you're sliding one magnet's north pole toward another's. You'd feel that unmistakable resistance, right? It's like an invisible wall. That's repulsion. You can literally feel the magnetic fields pushing back. Okay, now flip one of those magnets around. As the North Pole gets close to the South Pole, you feel the complete opposite, a clear, undeniable pull. And that, my friends, is attraction. So why does any of this matter? Why is understanding this simple little push and pull so important? Well, it's because this incredibly fundamental principle of polarity, it's the engine that drives some of our most advanced technology. Yeah, think about it. This precise control over attraction and repulsion is behind so much stuff. That rapid-fire push and pull is what powers electric motors. The massive, incredibly controlled magnetic fields in MRI machines, they let us see inside the human body. Even something as simple as a magnetic lock on a door is using this exact same fundamental principle. It is literally everywhere. And really, that's the big takeaway here. Just by understanding and mastering these simple rules of attraction and repulsion, we have built some absolutely incredible technologies. This invisible dance isn't just a cool science trick. It's a true cornerstone of our modern world. Which leaves us with a pretty cool thought to ponder. From the teensy tiny magnetic fields inside our phones to the absolutely massive magnetic shields that protects our entire planet, we are surrounded constantly by these invisible forces. It makes you wonder, what other secrets are they just waiting to show us?